Hello everyone. Today we are going to learn about a dynamic memory allocation in C programming. Let me start with a small story. Imagine you are going to organize the one event. You want to prepare a lunch for a guest, but you don't know how many guests will come until the event. If you are preparing a lunch, too many people, you waste a food. If you make it too few, some guests will go hungry. The same problem happens in a programming also. Sometimes we don't know how much memory is needed until the program is running. If you use a more memory than needed, it is wasted. If you use too little, our program won't work correctly. The starting memory allocation, like maybe if you are declaring a variable integer, array of hundred size, the size is fixed. Okay, before executing the program, we fix the size. We cannot change it at a runtime. But if you're using a dynamic memory concepts, we can increase and then we can decrease at the runtime. Okay, so we'll see one by one. So what is the dynamic memory allocation? Okay, so what is the dynamic memory allocation? So we can fix the we can allocate the memory at runtime. So we have a four function in a DMA concepts. One is a MLX function is mainly used to allocate a memory, allocates the memory in specified size. We have second function, one is a CLOC. It is also allocate a multiple blocks of memory. It will allocate a multiple blocks of memory. The expansion of MLOC is memory allocation. The expansion of CLOC is a contiguous allocation. The third one is a real. If you want to reduce and then if you want to change the size of your already allocated memory, now you can use a real function. And then fourth one is free of function, mainly used to deallocate or release the memory. Okay, we'll discuss one by one. First, we'll take a malloc function. So what is a malloc function? It's mainly used to allocate the multiple, so large block of memory. Okay, so the syntax or a malloc function is you can use a malloc. We need to mention this number of elements we are going to use it, number of elements multiply into data size. Okay, the malloc functions after allocating the memory, the malloc function will return only the void pointer. It will return a void pointer. So we need to convert this. So we are not, you already you know very well the void pointer is a general pointer or a generic pointer. We cannot use it directly for a integer element or a floating point element or a character elements. We need to convert the general pointer into a integer pointer, integer or float. So that the purpose we need to use a typecast here, typecast, typecast pointer. So void pointer converted into a integer pointer here, then it will allocate the, so the starting address will be stored into a pointer variable. Okay, for example, I want to store 5 elements. Okay, so I want to store 5 elements, but I need to create a memory for five elements, five integer elements. I have of 10, 20, 30, 40, 50. I need to create a data runtime. So how will you allocate the memory for this elements? Now we can use a malloc function. Malloc function. How many elements? 5. Multiply into size of function. So bracket we need to mention this type. We are going to use a integer, so we can mention this integer. Okay. So malloc function allocate the memory. How many bytes? 5 into size of integer na the 4 bytes. Okay, 4. So total 20 bytes of memory it will be allocated. How will you allocate it? It will allocate a large block of memory. 1, 2, 3, 4, 5. Okay. The starting address 1000, 1004, 1008, 1012, 1060. Okay. Okay. So after allocating this memory, the starting address will be sent to the pointer. So malloc will send void pointer. Void pointer, we need to convert the void pointer into integers. That's why we can use a typecast. So int star, this is the typecast pointer. After converting this integer pointer, so we have a one starting address 1000. How will you store the address? We need a one pointer variable. Pointer value will only hold the address of this variable. So that's why we need to declare a one pointer variable ptr. So it will allocate the memory for a pointer variable ptr. The address may be a 2000. Okay, so we have out of 1000, the 1000 will be assigned to the pointer variable. So after that, it will create a reference to this reference. Okay, this is the way we are allocating the memory for this element using a malloc function. Okay, once allocate the memory allocation of all the elements, the malloc didn't assign any values. So all the memory space contains only the car-based value. Initially, all contains a car-based value. You know very well about this car-based value. Okay, that's it. Next one is we are going to discuss about a CLR function. CLR expansion is continuous allocation. Okay, it will create a multiple blocks of memory, multiple blocks of memory. Okay, the syntax is CLR, and then we need to mention this number of elements, comma, and then data sets. We need to mention this data sets. In MLAC, we have mentioned only one parameter. Here we are mentioning two parameters. Okay. So we need to convert this CLR function also will return a void pointer. So we need to convert the void pointer into a specific pointer. So that's why we can use a typecast here. Typecast. And then finally it will return one starting address. No, so that's why we need to declare a one pointer variable. For example, I have a five elements 10, 20, 30, 40, 50. But I want to store this. I need to store five elements runtime. Okay, so you can use the CLR function. How will you write the CLR syntax? You can use this CLR. How many elements? Total of 5 elements. We need to mention this 5, comma, data size of int. Okay, it will allocate 5, comma 4. 5, comma 4. No? So 5, 4 bytes of element. 5, 4 bytes of memory it will be allocated. 20 bytes of memory it will be allocated. It will allocate a contiguous memory. 1, 2, 3, 4, 5. Okay, it will allocate 1000, 1004, 1008, 12, and then 16. Okay, so after allocating the memory, the CLR function will initialize the 0 to all memory spaces. That's the difference between MLOC and then CLOC. MLOC are having only the garbage value. The CLOC default value is 0. Okay, so we need to convert this. This is the void pointer. We need to convert the void pointer into integer pointers. So that's why we can use a typecast here int star. Okay. So finally, we need to store the starting address now. So that's why we can use a one pointer variable star ptr. So we have a pointer variable. Okay, this address may be 1500. Here we can store 1000 here. So it will create a reference. That is the concept of CLOC function, MLOC, and then CLOC. Okay, so I want to, I have already stored a 5 elements. Additionally, I want to store a 3 elements in the same memory means you can use a realloc function. Okay, that's why you can use a realloc function. Realloc mainly used to increase or decrease the size of your memory. At runtime, you can decide it. So already we have declared a one pointer variable. We have assigned this memory int star. I can use this malloc function pi into size of int. I have allocated memory. So it will create a memory for 5 elements. 1, 2, 3, 4, 5. So we can store 10, 20, 30, 40, and then 50. The starting address 1000, 1004, 8, 12, 16. The starting address will be stored into the pointer variable. So we can store it in 1000. So it will create a reference to this variable. Additionally, I want to store 3 elements. Okay, so maybe I have 3 elements in my hand 60, 70, 80 without deleting my old value. Additionally, I need to store my 60, 70, 80. How will you store this element in the same memory? So we can use a realloc function. We can increase the size of your memory. How will you increase? You can use this syntax. You can use the same pointer. We are going to use this integer pointer. You can use a realloc function. How to mention this pointer name, which pointers we are going to increase this size. We can use mention this ptr, and then how to mention this new size. We need to already we have 5 elements. Additionally, we are going to add 3 elements. Total 8 elements. We need to use it. The new size is 8 multiply into size of dz. So how many bytes it will allocated? 8 into 4. 32 bytes it will be allocated. So additionally, the same memory 1, 2, 3, 4, 5, 6, 7, 8. So already we have a 10, 20, 30, 40, 50. The starting address is 1000. We have a pointer variable. The pointer variable holding the address of this memory, and then it will create the reference. So based upon the address only we can traverse in this elements. So additionally we can store 60, 70, and 80 here. This is the concept of MLOC, CLOC, and then DLOC. Okay, we use this memory after completing our process. We need to release the memory, so that's why we can use a function, free of function. Okay, so to release the memory. Okay, how will you release the memory? You can use this syntax free. Can just mention this which pointer on the automation. After releasing the memory, we need to assign this null value to the pointer. This is the important concept. Okay, so this is the way you can allocate the memory at a runtime. Okay, so you can increase and then you can decrease the size based upon your requirement. You can allocate the memory. So From this concepts, you can manage your memory. We can avoid memory waste. Okay, this is the concept of dynamic memory allocation. Thank you.